Welcome aboard. Wow, that is bright. Welcome aboard. Today we're diving into one of the most trusted tools to monitor your boat's power system, the Victron BMV-712 Smart display.
Nice.
Whether you're running lithium, AGM, or lead acid, having accurate insight into your battery's state of charge, voltage, and current draw is essential to safely staying off grid with confidence. This unit right here is going into my own boat, which is now powered by a lead time 320 amp hour lithium battery. If you haven't seen those videos yet, be sure to check them out, episodes 1 and 2 of this series. A series that couldn't be possible without Defender Marine, who I want to give a big shout out for helping me get my hands on this Victron equipment, as well as all the supplies in the rest of the build series. They've been a huge supporter of the channel, and they carry just about everything you'll need out on the water with fast shipping, great prices, and incredible support. You can find their site along with this product in the description down below. Let's open up this unit and show what's inside. Right off the top, we have the BMV-712 display unit. It is only this big, sleek, compact, and styled in Victron's matte gray. Comes in this little baggie here for protection, along with a mounting plate and a couple small screws. Next up, we have the 500 amp precision shunt. This is the little piece of equipment that does all the heavy lifting and reads the boat's power. And lastly, in our concise little package here, we have a couple of wires. One of them is your VE direct cable that connects your display to your shunt. And the last two wires are power cables with fuses. These connect your battery directly to the shunt itself. Everything is clearly labeled, and the wires are even pre-prepared to make installation as easy as possible. But if you do end up with any questions, you can always reference the quick installation guide included inside the box. Or, you could just watch the rest of this video. Some reasons why I got this model and not other brands or displays is because I like the size of it. I think it takes up the exact appropriate amount of space necessary for you to read your battery's power. I have used this interface before, so I am somewhat familiar with the buttons. I do like that it has physical buttons instead of touchscreen buttons. And the primary reason I got this one over another one is because this one is Bluetooth, which means that it's future-proof for any more equipment that I want to add and connect to it. I'm able to display the data from it on an app, which means that one day I can monitor it remotely. This is important to me because I also got this GX unit that I'll one day use to connect all the boat systems into one place that I can monitor remotely and put on a chart plotter. Now that we understand all the pieces of the puzzle, let's see if I can show you guys how to put it together. Before we start, keep in mind, I'm connecting this with the goal of reading only a single lithium house battery bank. You can use it to read multiple battery systems. I, however, cannot because I have to have my house bank that is lithium isolated from my starting battery bank, which is lead acid. The only way they can be connected is through a charger. If you'd like to see that process, I did that in episode 2. Be sure to go check it out. I will, however, at the end show you how to connect the second battery bank system in the hopes that maybe it'll work for you if you can use it. So there's really only two parts to this installation, setting up the shunt and connecting the display. I'm going to start by setting up this shunt in this mess of an electrical cabinet that I hope to one day reorganize. I promise I'll fix it when I redo the dashboard, but for now, you'll just have to take my word for the fact it's all wired properly. It may look like the internal wirings of a schizophrenic, but it's all done right, I promise. Speaking of doing things right, before you start working on this, you should disconnect your negative battery terminal. This will prevent any unwanted power from damaging anything and also reduce your risk of meeting Mr. Shocky. Anyways, you're going to want to mount the shunt in between your battery's negative terminal and the rest of the vessel's load. This is because we don't want any electronics or power draw to happen after the shunt. This way, everything using power is being monitored and included in the displayed data. Once you have it mounted, you'll connect the load side terminal and then the negative side. For now, leave the negative disconnected from the battery until we are done. But when you are done, you want this side directly attached to the battery. At this point, you can move on to mounting the display. The display only has one cable that provides both power and data. It's the VE direct cable. It's pretty long at 10 meters, so the location of your shunt to your display can be a distance. Mine happens to be literally right next to each other. Once you have your hole cut out, you can either mount the display as a rounded face or use the square bezel if that's your boat's style. I think using the bezel with the 4 screws is probably the more secure way to go, but I always like to cut as few holes as possible in case in the future I want to change the unit to something else. I'm going to go with using the rounded face and securing it with the backing collar. Now that we have the display set up, we connect the VE direct cable, and just like that, we're on our last step. The final step is going to be taking that fused positive wire and connecting it directly to the battery's positive terminal. The other end connects to the shunt for power. Lastly, you can go ahead and reconnect the negative battery terminal, and you should be in business. With the interface lit up and functioning, we can start the setup process. It's really simple. First, input the battery's capacity. I have a 320 amp hour battery, so I set the display to that. Just use the plus and minus buttons to select the digits, and then push the select button to move on to the next. The display will then give you the option to select your auxiliary input. This is in case you want to display temperature or any of their other data options. I'm not doing that, so I just select none. Now the display will start working and display all the battery's data and the boat's power usage. However, on initial setup, the display assumes the battery is 100% charged, so it sets its current voltage as its 100% ceiling. The display will learn what 100% looks like if you input the correct battery settings, but I'm going to set mine manually as well. Up until now, all the info I've needed is from Victron's quick start guide, but since I'm installing a lithium battery and not a lead acid battery, there'll be some more complicated settings I have to adjust. The info about the rest of these settings are in the full manual. There is a way to change all these settings in the Victron display interface itself. However, I went ahead and got the BMV-712 Smart display, so I'm going to go ahead and do it in their app. The display will wirelessly connect to the app. They do provide a default code to try to use for pairing. However, my real code was actually on the back of the unit itself. Once connected, we can see the data from the vessel's power, and we'll need to navigate over to the settings. Here we can see that the capacity was set to 320 like we did earlier at the display, but the rest of the settings are pretty foreign to me. I don't know what any of these things mean. All I know is that they're set up for lead acid and we need to set it up for lithium. The only setting that looks a little familiar to me is the first one we'll do, which is the discharge floor. If you've watched my other two videos on this project, you'll know that a lithium battery can use almost all of its battery capacity without a drop in voltage, unlike lead acid. Lead acid can only use about 50% of its power before its voltage drops too low. You can see that here in the discharge floor setting. I'm going to go ahead and change my discharge floor to 10%. The rest of these settings I admittedly didn't look all that much into. The manual does a good job of telling you what all of these settings mean. Here you can see all my final settings in case you're running a similar battery setup. Always check with your manufacturer though. These settings have been working for me, but I'm going to take zero responsibility for running your battery dead. All these settings are primarily used to determine when your battery is at 100% state of charge. So if you do have some of these settings wrong, it could give you false readings. The main settings I changed were the charge efficiency factor to 99% and the Pukert exponent to 1.05. I also looked at this voltage chart from my manufacturer and determined that my battery's state of charge was actually closer to 25%, so I went ahead and manually set that as well. I actually completed this installation before I finished writing and filming this video, thus the outfit change. I needed to get it installed and working for upcoming trips. So now after the fact, I could tell you that a couple weeks later, I realized I could just use the Bluetooth feature on my lead time battery to tell me what its state of charge was. Which I did, and found out that they're actually both synced up and reading the same state of charge. So I nailed my guess, or my settings happen to be right, or a broken clock is right twice a day. I think that the monitor is smart and just learned on its own after a couple cycles what 100% actually looked like. Now the last thing I did in the settings was I went ahead and set an alarm in case the battery ever gets too low. The app is pretty good and has some nice features. I actually hope to one day connect it to a small computer for remote monitoring. Anyways, there's one last feature that I'm personally unable to use, but I'll touch on it anyways. There is a setting to monitor an additional battery bank. I can't use this because by using a lithium house battery and lead acid starting batteries, I have to isolate both battery banks from each other. This means that I can't connect them to that same smart shunt we installed earlier as a ground because my battery charger won't see different voltages and charge my lithium bank. But if you do have a different battery bank system that you'd like to also monitor, all you have to do is connect the ground to that smart shunt we installed earlier and then take a second positive fused wire and connect it to that second battery bank. But just like that, after 3 episodes, I have one operational and now monitored house lithium system. Pretty exciting to make this next step in the modernization of my boat. In the future, I hope to have all kinds of amenities like permanent refrigeration, a new live well, and even full-time internet. A big thank you again for Defender Marine for helping me get this Victron equipment. Don't forget to like and subscribe to see the next step, which is installing solar. And let me know what you guys think of this build in the comments down below. Smooth sailing. Now that we understand the pieces of the puzzle, let's see if I can't put it all together. This helicopter would leave me alone, which it won't. The birds don't leave me alone, helicopters don't leave me alone, the boats going by don't leave me alone, and the construction workers don't leave me alone. Flying over me, why not?